terminology that you have to remember. So let's look at number one. So the directions will probably say something like this. Perform the indicated operations and simplify. So perform the indicated operations and simplify. Okay, so number one, you have 2 square root of 6 plus 3 square root of 6. Okay, now remember, we're only dealing with square roots. Next week, you're going to be looking at cube roots and so on. But listen carefully. See, you have radicals here, square roots. You can combine radicals. And I'm going to use the word square root. You can combine square roots if the radicands are the same. Radicands are same. Okay, square roots, if the radicands are the same. So notice square root, square root. The radicand 6, the radicand 6. So it's kind of like saying 2x plus 3x. So recall 2x plus 3x are like terms, so that's just 5x. Same thing here. 2 square root of 6 plus 3 square root of 6 is 5 square root of 6. So that's your answer. And you cannot simplify the square root of 6 because the only perfect square that goes into 6 is 1. Okay, number 2. You have 7 square root of 10 minus 12 square root of 10. 7 square root of 10 minus 12 square root of 10. So notice that these are like terms because the radicands are both 10s. So 7 square root of 10 minus 12 of them is kind of like saying 7x minus 12x, and 7x minus 12x is a negative 5x. So that's going to be negative 5 square root of 10. And you cannot simplify the square root of 10 any further because the only perfect square that goes into 10 is 1. So that's the answer there. So that's the idea in terms of combining square roots. You can only combine square roots if the radicands are the same. So if you had something like this, 2 square root of 3 plus 5 square root of, let's say, 7, you cannot combine those. So this cannot be simplified. This can't be simplified because the radicands are different, since the radicands are different. All right, so keep that in mind. All right, number 4. Okay, now let's look at number 4. You have 2 square root of 6 minus 3 square root of 24. All right, now you may say, well, the radicands are different, so I can't do anything. Well, you got to be careful. Remember, when we talked about this, we said at this point, I cannot simplify the square root of 6 because the only perfect square that goes into 6 is 1. So what you want to do first is look at your radicals, the square root of 6. Can I simplify the square root of 6? The answer is no, because the only perfect square that goes into 6 is 1. Can I simplify the square root of 24? The answer is yes. So go off to the side and do that. Work that out right here. Because a perfect square that goes into 24 is 4. So this becomes the square root of 4 times the square root of 6. So you had things like this last week. So this becomes 2 square root of 6. So that 2 square root of 6 is this. So that's this right here. So what you're going to do? You're going to say 2 square root of 6 minus 3 times, and then we just saw that the square root of 24 is 2 square root of 6. Now say 3 times 2 is 6, so that becomes 2 square root of 6 minus 6 square root of 6. So that's the process you go through. So you will be asked to show work, and so that's the work you're going to need to do for something like number 4. Now number 1 and 2, there's no work to do. But for number 4, you will. You see the work you have to do. So you have to simplify. So you got to show the simplification and all that. And now those are the same term. I'm sorry, those are like terms, like L-I-K-E, like terms. Those are like terms. So I can combine them. 2 square root of 6, subtract 6 of them. 2 subtract 6 is a negative 4. So the answer is negative 4 square root of 6. And that's all you do. So first thing you got to do is simplify the square roots. We're dealing with square roots only today. So simplify the square roots, and that's what you do. All right, so number 5, let's do number 5. So number 5, we have negative 3 square root of 2 plus 3 square root of 20 minus 3 square root of 8. All right, so notice I have 3 terms, and you want to simplify each one first. So you may say, well, they all have different radicands. Radicand here is 2, the radicand here is 20, the radicand here is 8. You're right, they all look different. But when you simplify, some of them could be the same. So that's what you got to do. So ask yourself, can I simplify the square root of 2? The answer is no, because the only perfect square that goes into 2 is 1. What about the square root of 20? Well, let's think about the square root of 20. The perfect square that goes into 20, and always use the largest. We talked about that last week and probably the week before, but one of those weeks. The largest perfect square that goes into 20 is 4. So that's the square root of 4 times the square root of 5. And the square root of 4 is 2. So this becomes 2 square root of 5. So that's going to go here. So I'm going to write this as negative 3 square root of 2 plus 3 times, and this we just found to be this. So I always write it like this. It helps. And then minus 3 times. Now let's talk about the square root of 8. I can simplify the square root of 8 because 4 is the largest perfect square that goes into 8. So I can write this as the square root of 4 times the square root of 2. 4 times 2 is 8. And 4 is a perfect square, so the square root of 4 is 2. So that's 2 square root of 2. So that goes here. Now what I'm going to do now is I'm going to multiply 3 and 2 in both cases. So this becomes negative 3 square root of 2 plus 6, 3 times 2 is 6, square root of 5 minus 3 times 2 is 6, minus 6 square root of 2. So notice I simplified this to this, and I simplified this to this. I still have 3 terms, but notice that 2 of those terms are like terms. Square root of 2, square root of 2. So I can combine these two. A negative 3 and a negative 6. So if you look at the coefficient of the square root of 2, a negative 3 and a negative 6 is a negative 9. So this becomes negative 9 square root of 2 plus 6 square root of 5. And you can't do anything else because those are not like terms. This is square root of 2, this is square root of 5. Now let me show you that you can also rewrite it in a different order. So if you want to put the square root of 5 term first, you can. That will be 6 square root of 5 minus 9 square root of 2. So it does not matter the order in which you write this as long as you keep the signs with it. All right, so that's a process you're going to go through. And then next week, it gets a little bit more involved because you're going to have variables in all of these now. So right now, we're just dealing with numbers. Now you're going to be dealing with variables next week. Okay, number 6, you have negative square root of 45 plus 2 square root of 5 minus square root of 20 minus 2 square root of 6. So minus 4 square root of 5 plus 2 square root of 5 minus square root of 20 minus 2 square root of 6. And notice I have 4 terms, 1, 2, 3, 4. And you want to simplify each one. So let's look at that square root of 45 first. I can simplify this because 9 is the largest perfect square that goes into 45. So I can write this as square root of 9 times the square root of 5. 9 times 5 is 45. And the square root of 9 is 3, so that's 3 square root of 5. So that's going to go here. So that becomes negative 3 square root of 5. I cannot simplify the square root of 5 because the only perfect square that goes into 5 is 1. So that's going to say 2 square root of 5. Now let's talk about the minus square root of 20. So square root of 20. The largest perfect square that goes into 20 is 4. So it'll be the square root of 4 times the square root of 5. And the square root of 4 is 2, so that's 2 square root of 5. So that's going to go here. So minus 2 square root of 5. Now let's look at this one. Minus 2 square root of 6. The only perfect square that goes into 6 is 1, so I cannot simplify that. So the only two of these I could simplify is this one and this one. And there's the work. All right. Now let's go ahead and combine like terms. Make sure you understand that these three are like terms only because they all have the square root of 5. This is the square root of 6. So negative 3 and a positive 2 and a negative 2. So negative 3 square root of 5 and a positive 2 square root of 5. So negative 3 and positive 2 is a negative 1, right? And then negative 1 and a negative 2 is a negative 3. So when I combine those three, I get negative 3 square root of 5. And then all you do is bring this down, so it'll be minus 2 square root of 6. You cannot do anything else because these radicands are different. Now, if you want to put the square root of 6 first, you can. You'd say negative, keep the sign, negative 2 square root of 6 minus 3 square root of 5. Does not matter how you write it. All right, there's number 6. Let's look at number 7. So in number 7, we have five square root of 3 minus square root of 12. 5 square root of 3 minus square root of 12. So I cannot simplify the square root of 3 because the only perfect square that goes into 3 is 1, but I can simplify the square root of 12 because I can write 12 as the square root of 4 times the square root of 3. So the largest perfect square that goes into 12 is 4. So this becomes 2 square root of 3. So that's going to go here. So this becomes 5 square root of 3 minus 2 square root of 3. And that's an easy one because those are the only two terms, and now they are like terms. 5 subtract 2 is 3. So the answer is 3 square root of 3. Number 8, we have 3 square root of 2 plus 2 square root of 8 minus 3 square root of 18. All right, so again, I cannot simplify this one because the only perfect square that goes into 2 is 1. But I can simplify the square root of 8 because the square root of 8 is the square root of 4 times the square root of 2. And the square root of 4 is 2, so that's 2 square root of 2. So the square root of 8 is this. So that's going to go here. Now be careful how you write it. So it's 3 square root of 2 plus this 2 times, and this is now this, 2 square root of 2. Minus 3 times, now let's figure out what the square root of 18 is simplified. So the largest perfect square that goes into 18 is 9. So it'll be the square root of 9 times the square root of 2. And the square root of 9 is 3, so that's 3 square root of 2. So that's going to go here, 3 square root of 2. Now I'm going to go ahead and multiply these two factors together, and then these two factors together. So now I get 3 square root of 2 plus 4 square root of 2 minus 9 square root of 2. And now notice those are all like terms because they all have the square root of 2 in it. So 3 plus 4 is 7. 7 subtract 9 is a negative 2. So the answer is negative 2 square root of 2. Number 9, we have 5 square root of 7 minus 2 square root of 28 plus 6 square root of 63. So 5 square root of 7 minus 2 square root of 28 plus 6 square root of 63. So again, we have three terms, and you want to simplify all of these if you can. I cannot simplify the square root of 7 because the only perfect square that goes into 7 is 1. Now let's look at 28, square root of 28. The largest perfect square that goes into 28 is 4. So I can write this as square root of 4 times the square root of 7. That's a 7. The square root of 4 is 2, so that's 2 square root of 7. So that's going to go here. So I have this. I have 5 square root of 7 minus 2 times this 2 square root of 7 plus 6 times and then let's figure out what the square root of 63 is. So the largest perfect square that goes into 63 is 9. That's the square root of 9 times the square root of 7. 9 times 7 is 63. The square root of 9 is 3, so that's 3 square root of 7. So that's going to go here, 3 square root of 7. And what we do now, just like I did this one, I'm going to multiply these factors together. 2 times 2, 6 times 3. So I get 5 square root of 7 minus 4 square root of 7 plus 18 square root of 7. And then all you do now is combine like terms. 5 subtract 4 is 1. 1 plus 18 is 19. So I get 19 square root of 7. All right, number 10. So number 10, we have negative 3 square root of 12 plus 3 square root of 3 plus 3 square root of 20. And again, we're going to simplify each one of these. There are 3 terms. So let's look at the square root of 12. So the square root of 12 I can write as the square root of 4 to the square root of 3. 4 is the largest perfect square that goes into 12. So that's 2 square root of 3. So I'm going to rewrite this as negative 3 times, and I just found the square root of 12 to be this, plus, and then 3 times the square root of 3. I cannot simplify the square root of 3. The only perfect square that goes into 3 is 1. Plus 3. Now the square root of 20 is the square root of 4 times the square root of 5. 5 times 4 is 20. And the square root of 4 is 2, so that's 2 square root of 5. So it goes here. 3 times 2 square root of 5. And then what you're going to do now is just multiply these factors together, right here, these 2 and these 2. So negative 3 times 2 is a negative 6. I get negative 6 square root of 3, plus 3 square root of 3, plus 6 square root of 5. Now notice that only these 2 are like terms. So negative 6 square root of 3 plus 3 square root of 3 is a negative 3 square root of 3. Plus, and then 6 square root of 5. And that will be the answer there. Now, if you want to rewrite the order, you can. You could say 6 square root of 5 minus 3 square root of 3, as long as you keep the signs with it. All right. So that is 10 problems on adding and subtracting square roots. Now, in the next lesson, you're going to have variables with these. And you're also going to be dealing with multiplying those and dividing those rather than just adding and subtracting. All right, so that'll be the end of that.